Okay, next we have energy and wave motion, and we will calculate the kinetic energy, potential energy, total energy, power and intensity, and wave motion. Before going into the wave motion, I will discuss a little bit about simple harmonic motion, motion of a body which is simple harmonic. Suppose we have a simple pendulum. I will consider the simplest example, which is simple pendulum. Suppose we have a simple pendulum, a body of mass m, which is attached to a string of length L, and the string is hanged with some support. Suppose this is the support. If I displace this particle or this simple pendulum from its mean position, I call this mean position as O, to, let's suppose, here to up to this point. Now I can consider the point to be this one. Yes. Then this pendulum oscillate will follow this path during its motion, and it oscillate in this way. It start from this point. Let's say this is point A. It move towards point O, mean position, and then it goes towards another point. This is point B. Here this pendulum, this bob or this mass velocity becomes 0. I can write this way, like the particle or the mass move in this way between point A and point B. Now at point A, the kinetic energy is 0 and potential energy is maximum. Once it moves from point A to point O, then kinetic energy increases, potential energy decreases. At point O, kinetic energy become maximum and potential energy become 0. As it moves from point O to point B, then what happens? Kinetic energy decreases, potential energy increases. Once this mass reach to point B, then here we have kinetic energy, which is again 0, and potential energy, which is maximum. So at this point, total energy, I call it E. Yes, I call it E, which is the sum of kinetic energy plus potential energy. Here also the total energy, which is the sum of kinetic energy plus potential energy, and here the total energy, which is the sum of kinetic energy plus potential energy. So the total energy of the this pendulum, this mass, is always constant, while its kinetic energy and potential energy changes from position to position. So at a given point, like at point A, if kinetic energy is minimum, potential energy is maximum, and total energy is also maximum. At point B, point O, what happened? Kinetic energy become maximum, potential energy become minimum, 0, while total energy remain constant. So if we plot the energy diagram of this simple harmonic motion, then this particle move between 2 points. This is for the kinetic energy, and this is for the potential energy. This is for the potential energy, and this is for the kinetic energy. And this one is, I use a different color here. This one is the total energy. So at extreme positions, like when the body or the bob covered the maximum displacement, like at maximum displacement, then the kinetic energy is potential energy is maximum. Let's see here. Potential energy is maximum, while kinetic energy is minimum at the extreme position. While at mean position, kinetic energy become maximum, while potential energy become minimum. So we can say that at a point, if kinetic energy is maximum, then potential energy will be minimum, but the total energy will remain constant throughout this motion, and the total energy is this one. Now in case of wave motion, in case of simple harmonic motion, if kinetic energy is maximum, is a maximum value, then potential energy will be minimum. So if potential energy is minimum, then the total energy, which is E, will remain constant throughout this motion. If I say that if kinetic energy is minimum at a given point, then potential energy will be maximum at that point, while total energy will remain constant. This is for the simple harmonic motion. But in case of wave motion, the situation is completely different. Now if I draw this motion diagram, then the motion looks like this. Here at this point, kinetic energy become minimum, and potential energy is maximum at this point. Here at this point, kinetic energy is maximum, while potential energy is minimum. This is simple harmonic motion. Here on this side we have the displacement, on this side we have the displacement, and on this side we have the angle theta. So this is all about simple harmonic motion. Now if we discuss wave motion, in case of wave motion, if kinetic energy is maximum at a given point, then potential energy will also be maximum at that point, and then total energy, which I represent by this E, is also maximum at that point. So look at this. In simple harmonic motion, if kinetic energy is maximum, potential energy is minimum at a given point. But here the situation is different. If kinetic energy is maximum, then potential energy is also maximum at that point, while total energy is also maximum at that point. If kinetic energy is minimum at a given point, then potential energy will also be minimum at that point. So if both are minimum, then this implies that total energy will also be minimum at that point, because total energy is the sum of kinetic and potential. If both of them are minimum, then their sum will also be a minimum number. So this is completely opposite. Here in this simple harmonic motion, in case of wave motion, the total energy does not remain constant. while in simple harmonic motion total energy is always constant at every point, but in case of wave motion total energy is not constant. So we will derive a formula and we will discuss all these facts, that why if kinetic energy is maximum, then why potential energy is maximum at that point, and why total energy is maximum at that point. And similarly, if kinetic energy is minimum at a given point, then why there is the potential energy is minimum at that point, and why the total energy is minimum at that point. We will discuss all these facts by deriving a relation for all the three quantities, for kinetic energy, for potential energy, and for total energy.